Just to do a quick review of what we went over last time. Blood has several functions in addition to just toting our oxygen around, right? Carrying our oxygen around is probably the most important function blood has for us. But it also has an immune system function because we have white blood cells in there. It is also responsible for body temperature, pH regulation. There's a lot of other stuff that blood does. Blood has two parts, the liquid part and the more solid part. Okay? The liquid part is the plasma, mainly water. You do have some proteins, some other stuff in there, gases, but it's mainly water. The formed elements are your erythrocytes, your leukocytes, and your platelets. What are erythrocytes? Red blood cells. What is the only thing found in a red blood cell? Hemoglobin. What does hemoglobin do? What binds to hemoglobin? Oxygen binds to hemoglobin. You have 4 hemes, 4 iron molecules in each molecule of hemoglobin, and that iron, each one of those can bind an oxygen. So you bind 4 oxygens for every molecule of hemoglobin. Okay? What are leukocytes? White blood cells. There were 5 types of leukocytes, and I told you as of right now, the only thing you really need to be able to do is just kind of tell me the basic function of each 5, because we're going to go over those as we get into the immune system a lot better. Okay? All of your leukocytes travel around your body in your blood and come out of your blood when needed by a process called diapedesis. Okay? We're going to talk more about that also later. 5 types of white blood cells. The first type is a neutrophil. What is a neutrophil? Your phagocytic cell. Phagocytosis means eating other things. Your neutrophil is your white blood cell that says, oop, here's a bacteria, let me eat it and kill it. Okay? What does an eosinophil do? Attacks worms. Okay? What does a basophil do? Releases histamine. What does the histamine do? Attracts help. It's the tattletale, calls for help. Very good. What does a lymphocyte do? Kills lots of stuff. Kills viruses, cancer cells, bacteria. Your lymphocytes are your T cells and B cells. And we have a whole chapter to learn what those guys do. Okay? They're the complex cells. Last type is the monocyte. What does a monocyte do? Becomes a macrophage, which is a very phagocytic cell. Okay? That's as detailed as you need to get with those 5 types of cells. Okay? And that, I believe, is kind of where we left. Oh, last one, platelets. What do platelets do? Blood clotting. And that's where we left off. And our next topic is actually looking at how those platelets accomplish that blood clotting. Okay? This is an example of them trying to use pretty complicated terminology to explain something that's pretty simple. So let me explain it the simple way, and then we'll look at the real terminology. If I get a cut in a blood vessel wall, that's going to be now a rough spot, right? It was a nice, pretty smooth blood vessel, and I cut it. So now there's a gap. There's damage. That rough spot is going to attract a platelet. As the blood is flowing through, things are hitting that rough spot. As the platelet hits that rough spot, it realizes that means it needs to stick to that rough spot. And when one platelet sticks, they start sending out signals that make other platelets want to stick. And you end up with a whole clump of platelets stuck together. That is a very temporary fix. Once the platelets all stick in there and make a clump, they start releasing things that combine with proteins in your blood to form a more permanent protein patch. That's what a scab is. Okay? So why is it bad to pick a scab off? Because it's still healing. And your blood had worked so hard to build that scab, and when you rip it off, your blood's got to build a new one. I agree it's fun. Everybody likes to peel a scab off and see what happens. We just, for some reason, we got to see what's underneath. But it's bad to do because your body has worked so hard to build that scab. And it's just got to make another one. Okay? Now, that's easy to understand, right? So let's look at proper terminology. The first part of this is called a vascular spasm. What do you think of when you hear spasm? Like a muscle spasm is a contraction. A vascular spasm is the blood vessel diameter is going to decrease. The blood vessel constricts. So what's the easy way to explain that? If I cut my arm, do I want the blood to just keep gushing as fast as it can out of there? No, for a couple of reasons. I don't want to lose my blood, but also it's harder for those platelets to stick if the blood is flowing really fast. So the first part is we decrease the diameter by a vasoconstriction. Constrict the blood vessel, slow blood flow. Okay. The second part is the platelet plug forms. Okay. That's when the platelets literally start sticking. As you get a nice big clump of platelets sticking, you start releasing a whole bunch of stuff, but the most important one I want you to look at is the platelets release something called the thromboxane. Thromboxane is your big signal that's going to lead to our next step. Okay? Now the third part, what I described as making the scab, that's coagulation. Okay? That's actually stopping the movement of the blood. Okay? What's going to happen is that thromboxane causes the release of prothrombin, okay? The prothrombin activator, that activates prothrombin. Prothrombin then turns into thrombin. I know this sounds horrible, but thrombin combines with fibrinogen, ultimately forming, here's the important word, fibrin. Fibrin is the name of the protein that makes the scab. But what you should be able to get from this is not the name of every word throughout the steps, is that it takes several steps. You're activating this cascade of reactions that ultimately leads to fibrinogen that's already in your blood being converted into fibrin. Okay? You need to understand that the platelets aren't actually making the protein. They're just releasing something that changes the proteins in the blood so it will clot. Why do you think we need 15 steps in that pathway? Why not just let the platelets start releasing proteins and blocking the blood? What would happen if they did that by accident? Of a serious blood clot. And blood clots are bad, right? I mean, we all know that. We want our blood to continually flow. So we have a whole bunch of steps in here just to make sure we don't get a clot when we don't want to. Okay? So the big chunk of platelets comes together, releases thromboxane. That causes them to release prothrombin activator. That activation now sets into motion all these events. Then ultimately, we're going to activate that fibrinogen, something already in our blood, making our fibrin. Fibrin is the protein that forms the clot. That make sense? Yes, ma'am. Okay. Okay. Simply do different types of skin on your body respond faster to a blood clot. And the reason those areas on a female body don't heal as fast is because naturally they're supposed to be able to tear, go back together, tear, go back together. The more of a scab that forms, the more of a scar tissue you're going to form. So if you don't really want scarring to occur, you don't really want to see a big scab. Have you guys ever noticed that? If you cut yourself and it doesn't scab, you can't ever tell again that you cut yourself there. But if you cut yourself and you get a big scab, that's going to lead to scar tissue. Because the larger it is, the harder it is for the epithelial tissue to actually just grow back together. So when you cut yourself somewhere like that, the epithelial tissue has this wonderful ability to really grow fast and grow back together so you don't scab. That's why it keeps bleeding, because the scab doesn't form. The fibrin clot doesn't form. So that's not the complete answer, but that's kind of a short answer. Do you have a question? You're stretching. Okay, go ahead. You do have scar tissue, but now that they cut this way with a C-section, that's the natural tension lines, the way the skin lays. so it doesn't scar as much, and you don't get as much scar tissue. But most of the pain that comes from the C-section is not the scar tissue forming, it's the muscles trying to reattach, which is bad, which is painful. They do reattach. It just takes time. It takes time. Thromboxane and prothrombin activator, no, that's 2 steps. Thromboxane comes first, and then that, after you get enough thromboxane, that's like, okay, this really is a clot. Okay, now the big clump of platelets, go ahead and release the prothrombin activator. That activates prothrombin. So it's a series of steps. Each one is a separate step. Okay. This textbook doesn't really have a very good picture. If this kind of confuses some of you guys, let me know, and I'll email you a better picture from an old textbook that I think was much better at showing you the steps, the little everything interacting together. So if this still bugs you, I've got some other sources we can go to. All right, last part. 2 slides, right? Why do we need 30 minutes to go over it? Because it's confusing for some people. Some of you will see it the first time, and you'll say, great, I got it, can I go? Some of you will want me to do it 400 times, and then it'll stick. It's not that it's that hard. It's just some people's brains have a better ability of just grabbing it than others. It's not an intelligence marker by any means. All right. Red blood cells don't have much on the inside of them. They got a lot of protein sticking off of them. Okay? Most of you probably have heard of type A or type B blood or something like that, right? Those aren't the only things sticking off of your blood cells. We consider that our blood type because those are the ones that can cause a bad immunological reaction. Okay? There are other things, but these are just the most important ones we have to worry about. Okay? So if we have a red blood cell, it's going to have things sticking off of it, little proteins. The proteins sticking off of the surface are called antigens. Okay? You may have A antigens. You may have B antigens. Okay? You may have only A. You may have only B. You may have both. You may have neither. So I'm going to have to draw them all out for you to be able to see it. But those are A's and B's are some of your most common antigens you may have on the surface. Your textbook doesn't use the word antigen. Your textbook uses the word agglutinogens. But I can't do it that way. It messes me up. I don't know why. Because I have never used that terminology before, and for some reason it confuses the heck out of me. So when I give you a test, every time I write the word antigen, I'm going to put agglutinogens in parentheses next to it. So they mean the exact same thing. Okay? I'm your teacher and your instructor. It's the same thing, right? Just 2 different words for the same thing. All right. Now, if you have, let me just go to my little piece of paper so I can draw a little bit more. All right. So if I am type A blood, then my red blood cell has only A's sticking off of it. Okay? If I have type A blood, I can never make antibodies against A antigens. Antibodies are proteins that float around in your blood and react to antigens. Okay? If I had antibodies against A, my antibodies would destroy my blood. Right? And I want my blood to be destroyed. So I can't ever have antibodies against A. But since I don't have any B antigens, I will have antibodies against B. And that's always abbreviated as anti-B. It's written in your notes. The other word for an antibody is an agglutinin. And I can't even say it. I think that's one reason I don't like that terminology. Okay, we're going to call them antigens and antibodies. So everybody's with me. This is A antigens, B antibodies. This is type A blood. Okay? Now let's do type B. So what type of antigen is he going to have? He's going to have actual B's on the surface of his red blood cells. What type of antigens can he have? A. He'll have anti-A. See, this isn't hard, right? Okay. So what about somebody that's type AB? Anybody in here type AB? I am. It's actually it's a pretty, you know, certain types of it are rare. All right, so what's AB going to have? What on his surface? He'll have some A's and some B's, right? Page a little bigger. Okay. What type of antibodies can he have? None. That's the correct answer. Why? Somebody said anti-A. Can he have anti-A's? No, it'll kill his blood. Can he have anti-B's? Nope, they'll attack his blood. He has no antibodies. It's actually a good way to be, and we'll talk about why in a second. The last blood type is type O. What's he got on his surface? Nothing. Not nothing, but he doesn't have A's or B's. Okay? What antibodies does he have? He has anti-A and anti-B. I'm so sorry, this is so nasty and messy looking. Okay? So I wrote all that down one side. Why? Who in here knows their blood type? What's your blood type, Angela? A, negative. What's your blood type? O, negative. We got to figure out what that positive and negative is, right? Okay. Positive and negative refers to another very important protein we sometimes see on people's red blood cells. Okay. It's called the Rh antigen. If you are positive, you have Rh antigen. If you are negative, you do not have Rh antigen. So let's change this side to our positives, and then we'll do the negatives right next to it. So in order for this to be type A positive, we've also got to put the RH on there because he's positive. Does everybody understand that? So if he's B positive, we need some RHs on him. He's AB positive, we need some RHs. O positive, we got to put some RHs on there. Okay. Can anybody that has positive blood have an antibody against Rh? Think about that. If I have A's, can I have anti-A's? No. So since all these have RHs, can they have anti-RHs? No. So does everybody understand that sentence? All right, let's draw the negatives, and then we'll put the whole picture together. If we are type A negative, can you guys tell me what's going to be on the surface? That's it, right? He's negative. Can't have RHs. So what antibodies is type A negative going to have? Everybody? He's got anti-B because there's no B's on his surface. And he's got anti-RHs because there's no RHs on his surface. Okay? Just to make our little chart complete for those of you that are drawing it. Okay? So B negative, what's he got? He's got B's. What antibodies? Very good. Anti-A, anti-RH. Good, y'all getting faster. That tells me that you're understanding. Type AB negative, what's he got? A and B. What antibodies? Anti-RH. Okay. And finally, type O negative has what? He ain't got nothing. So what antibodies does he have? A, B, and RH. He's got all three antibodies. Okay? What we're going to look at now is the idea of mixing blood together. The only time we're going to mix blood together is when somebody gets a blood transfusion, a blood donation, or when, what's the other example of blood mixing together? When a woman's pregnant. Okay? If you ever had somebody tell you that when a woman's pregnant, the mama and baby's blood doesn't mix, they lied to you. Okay? It does. Okay? It's not just one giant pool of blood, but there are things that share. Okay, so if we think about blood donations, I'm going to flip back to the notes for just a second to show you this next slide. We think about transfusion reactions, there's only one thing we have to worry about. And I think I may have made a mistake, so let's just change these words. In fact, I know I made a mistake because I figured it out yesterday. I hate those words. You mark those words out. And here's what's important when you do a transfusion reaction. Okay? You are only worried about your donor's antigens. Yeah, I did make a typo on your PowerPoint, so we're fixing it now. You worry about your donor's antigens and your recipient's antibodies. So those words, agglutinins and agglutinogens, I switched them. Sorry, that's just because I don't use those words. I was trying to do it the way your textbook does, and I can't. Okay? So that's what's important to remember. We all know what the word donor means. Who's the donor? Person giving the blood. Who's the recipient? Person receiving, getting the blood. So why is this the only thing that matters? Because when you are the recipient, when you're getting the blood, yes, you have antigens. You've got a ton of antibodies too. When you get blood donated to you, the donation blood has very few antibodies in it. So we don't have to worry about those antibodies of the donor reacting with the recipient. So if you can keep that sentence straight in your mind, this will be easy. Okay? So that's our goal. Worry about donor antigen, recipient antibody. So y'all are going to have to call these examples out to me because I'm going to flip to a piece of paper. Okay? So let me get a new one. Okay. So we have the donor, and we have the recipient. And we said we're worried about the donor's what? Antigens, and the recipient's antibodies. And guys, when I give you a test, draw it out. I still draw it out, and I've done this a million times. You'll see me up here taking the test with you, making my key, drawing my little red blood cells to see if it works or not. Okay? So give me the first example on the PowerPoint that I gave you. Who's the donor? The donor's AB positive, and the recipient is B negative. Okay? So we're worried about the donor antigens. So we got to draw a red blood cell. What antigens are on the surface of that donor's red blood cells? A, B, and RH, right? Okay? We're worried about the recipient's antibodies. It's easiest to figure out the antibodies if you draw the antigens. So let's get our red blood cell. What antigens does somebody that's B negative have? B. What antibodies does he have? He's got anti-A and anti-RH. Can this blood transfusion occur? No, why not? Because the anti-A's in your blood is going to clot with the donation blood. The RHs in your blood are going to clot with the donation blood. If you gave somebody that was B negative, AB positive blood, they're going to have massive blood clotting. And they could actually die from that. Okay? So the next time that little guy or little girl takes your blood at the hospital, realize they're doing a whole lot more than just taking your blood. Because if you came into that hospital and you needed a blood transfusion, your life is in their hands when they get your blood typing right or not. If it's a rush, they're going to give you one that everybody can get. We're going to get there in a second. All right, does that make sense? Okay, so let's do our next example. Okay. Who's my donor? B negative. Recipient? AB positive. Okay, so just flipped it. See, can it go the other way, right? So what is the antigen on my B negative? B. We don't care about the antibodies, right? Because this is the donor. What is the antigen on my recipient? B and RH. What antibodies does the recipient have? None. He has no antibodies. Can this transfusion work? Yes, because AB positive doesn't have any antibodies. So why do we call AB positive the universal recipient? He can get any type of blood there is. You can give it to somebody that's AB positive because they don't have any antibodies that are going to react to it. I'm AB positive. That's the best one to be if you're worried about getting a blood transfusion. Okay? Say that again. Even though they have all the antigens, it doesn't matter. Simply because they have no antibodies, you can get any blood. Okay? Everybody got that one? Let's keep going. Let's do some more examples. And when we're done, if you still don't get it, the rest of you can leave, and I'll hang out with whoever don't get it. We'll keep going until everybody gets it. All right, let's do number 3. Who's the donor? AB positive again? A positive, okay? Who's the recipient? A negative, okay? What antigens does my donor have? He's got A, and he's got RH, right? We don't care about his antibodies. He's the donor. What antigens does my recipient have? Don't know how many B's. Recipient, he's A negative, so he's only got A's. Okay, there's just more lines on there. So what antibodies does my recipient have? Anti-B, because there's no B's on the surface of the cell, and anti-RH, because there's no RH on his surface, right? Can this transfusion happen? No. The anti-RHs of the recipient will react with the donor blood, clot the blood. Is it getting better the more we do it? That's kind of why we do it so many times. All right, so I'm sure the next example is going the other direction, right? Look, I actually thought when I wrote these notes. Aren't y'all proud of me? Okay. Different color. So now we're A negative on the donor side and A positive on the recipient, right? Okay. What antigens does my donor have? A. Don't care about his antibodies. What antigens does my recipient have? A and RH. What antibodies does my recipient have? Only anti-B, because that's the only thing not on his surface, right? Can this transfusion happen? Yes. So I'm doing it both ways to prove a point, right? Just because it doesn't work one direction doesn't mean it can't work the other way, right? It's actually easier to transfuse somebody that's positive, because if you're positive, you can get negative or positive. If you're negative, you can kind of only get negative. All right, there's got to be some more examples with some O's on there. Okay. Okay. Thank you. Okay. O negative is my donor. What antigens does he have on his surface? None. Okay. What antigens does my recipient have? B. Doesn't have RH because he's negative. Okay. Got B's. What antibodies does he have? Anti-A, anti-RH. Can that transfusion happen? Yes. So why is O negative known as the universal donor? He can give blood to anybody, right? Why can O negative give blood to anyone? You don't have any antigens. There's nothing on that blood when you get it for your body to react to. So that's why O negative is universal donor. If you have O negative blood and you've ever donated blood, they probably call you once a month and say, hey, would you like to come donate blood again? Some of y'all are saying, yes, they do. I'm AB positive. They very rarely want my blood, because the only people that can really get my blood are other people that are AB positive. So I'm not in high demand. But if you're O negative, you are in high demand. Okay? If you're O negative, though, you can only get O negative blood. Okay? Are there any more examples? Okay, so let's do that last one, and then I'm going to show you something interesting. So you said O positive and what? Okay. O positive and AB positive. Okay. If I'm O positive, what antigens do I have on my surface? Only the RH. That plus tells me there's an RH on there, right? If I'm AB positive, what antigens do I have? AB and RH, right? What antibodies do I have? None. So can this happen? Yes. If I changed it to an AB negative recipient, can that transfusion happen? No. Some of you can predict it, right? Because he's going to have A's and B's and no RH, so he's got anti-RH. So that transfusion can't happen. Okay. My best advice to you is if this is still confusing, let's just sit down and let's just do more and more examples together. The more examples you do, the more likely it is to stick. I want to show you guys one other thing. There's a condition known as Erythroblastosis Fetalis, okay, which sounds bad, I know, but let me just show you what it is because it's kind of interesting. Erythroblastosis Fetalis occurs when a mother is negative. Okay? It doesn't matter if you're A negative, B negative, AB negative, or O negative. If you're negative, I just wrote A because that's the first thing that popped in my head. Okay? If you're a mommy and you have the negative, if you're negative for the RH antigen, you're going to have anti-RHs, right? Okay? If daddy happens to be positive, okay, he's not going to have any RH antigen. That doesn't matter. They can have sex because the blood doesn't exchange during sex. So that's not what we're concerned about. But if they make a baby, the offspring ends up being positive like the daddy, then the baby's going to have RHs on the surface. What is mommy's blood going to do to baby's blood? Clot the blood and can cause a miscarriage. It can cause, death of the fetus. All right? Have you guys ever heard of this? Rhogam. That's the RH factor shot. If you are a woman that is negative and you go into the hospital, you go to the doctor and they find out you're pregnant, they're giving you the Rhogam shot. They're not going to blood type daddy and all that because you may be wrong about who daddy is and they don't want that to be a possibility. If you're negative, they're going to give you that Rhogam shot. What it does is it neutralizes the anti-RHs so your blood will not destroy the baby. It's usually more prominent in the second child than the first child. Usually the mother's body won't attack the first baby too much, but the second baby, the mother's body is more amped up to attack that RH factor on that baby's blood, and it can be pretty serious. So, and like I said, I'm not going to give you a big test on this. I just think it's really interesting that something as simple as the protein on your red blood cell can cause a baby to not be able to develop. If both parents are negative, it does not matter. It's only when mother is negative and daddy is positive. It's the only time it matters. If you're negative and if you're a woman that's negative, they're giving you the shot regardless because they don't know for sure that man is really the father. And you guys laugh, I mean serious. As a medical professional, they don't really know who daddy is, and they're not going to take that chance of the baby dying just because you're wrong. Okay? All right, does anybody have any questions about blood typing?